A nebula is a vast, diffuse cloud of gas and dust in space. These clouds are the birthplaces of stars and planetary systems, and they play a crucial role in the life cycle of galaxies. Nebulae come in various shapes and sizes, and they can be observed in different wavelengths, including visible light, infrared, and radio waves. The formation of a nebula in interstellar space involves several key processes. Formation of nebulae. Gravitational collapse. Nebulae typically form from the gravitational collapse of regions within interstellar space. These regions, often composed of molecular hydrogen gas, are called molecular clouds. The collapse is triggered by various factors, such as shock waves from supernova explosions, the influence of nearby massive stars, or the collision of different molecular clouds. Molecular clouds. The primary component of nebulae is molecular clouds, large and dense clouds of gas and dust composed mostly of molecular hydrogen, H2. These clouds can have masses ranging from thousands to millions of times that of the Sun. Cooling and condensation. Within molecular clouds, temperatures and densities are relatively low. As the gas in a molecular cloud contracts under the influence of gravity, it cools further. This cooling process allows atoms and molecules to combine and form dust particles and icy grains. Protostar formation. As the gravitational collapse continues, regions within the molecular cloud become denser, and material begins to accumulate at the center. The accumulating material forms a rotating, flattened disk around a central concentration of mass. In the center, a protostar begins to take shape as the temperature and pressure increase. Accretion and star formation. The protostar continues to accrete mass from the surrounding disk. As the mass increases, the core temperature rises, and nuclear fusion reactions begin. Once the internal temperature is sufficient for sustained nuclear fusion, a young star is born. The remaining material in the disk may form a surrounding planetary system. Emission nebulae. Some nebulae are classified as emission nebulae because they emit light. Young, massive stars within a nebula can ionize the surrounding gas through their intense ultraviolet radiation. This ionization causes the gas to emit light of various colors, often giving the nebula a vibrant appearance. The Orion Nebula is a well-known example of an emission nebula. Reflection nebulae. Reflection nebulae do not emit their light but instead reflect the light of nearby stars. Dust particles within these nebulae scatter and reflect the starlight, creating a bluish glow. The Pleiades star cluster is associated with a reflection nebula. Dark nebulae. Dark nebulae are dense clouds of gas and dust that obscure the light from background stars. They are often seen as dark patches against the brighter background of the Milky Way. These nebulae are sometimes referred to as stellar nurseries because they can give rise to new stars. Planetary nebulae. Planetary nebulae are shells of ionized gas ejected by certain types of stars during the later stages of their evolution. These shells are often symmetrical and can have intricate shapes. The Helix Nebula is an example of a planetary nebula. Supernova remnants. Nebulae can also form from the remnants of massive stars that have undergone supernova explosions. These remnants, known as supernova remnants, contain expanding shells of gas and dust ejected during the explosive event. In summary, nebulae form through the gravitational collapse of molecular clouds, leading to the birth of stars and planetary systems. The diverse types of nebulae observed in space, including emission, reflection, dark, planetary, and supernova remnants, provide valuable insights into the processes occurring within these dynamic and evolving regions of interstellar space.